Well, we need to find the charge on each of the capacitors in this circuit. So for starters, C1 and C4 are going to be in series with this combination C23. Now C2 and C3, if you consider the voltage on this side and the voltage over here, those are going to be at the same voltage, so they're in parallel. So I'm going to start by combining those two into a single capacitor. I'm going to call that capacitor C23. So I'm going to have C1 here, C4 here, and C23 here. Now since they're in parallel, I add up the capacitances, right? So C23, C2 plus C3, and that's 5 microfarads, right? And then now C1 and C3 and C4 are all in series, so I can combine them into a single total capacitor here, C total. And since they're in series, I would say 1 over C total is going to be 1 over C1 plus 1 over C23 plus 1 over C4. And if I calculate C total, that's going to be 0.69 microfarads. Now delta V total is 24 volts over here, and so that gives me Q total, which is 16.55 microcoulombs. Alright, now since this capacitor has a charge of 16.55 microcoulombs, and these three capacitors are in series, they all have to have the same charge, right? We know that Q total is equal to Q1 is equal to Q23 is equal to Q4. So I know then that Q1, rounding off to 2 sig figs, is 17 microcoulombs, and Q4 is also 17 microcoulombs. So that takes care of those two capacitors. I'm done with those. Now I've got to consider the capacitor C23. So I know Q23 is 16.55 microcoulombs, and I know that C23 from up here is 5 microfarads. So doing a little math there, delta V is Q over C. That gives me 3.31 volts for that voltage difference. Okay, and if the voltage difference across here is 3.31, that means the voltage difference from here to here, and the voltage difference from here to here is 3.31. So delta V2 is 3.31 volts, which means Q2 is 6.6 microcoulombs, and delta V3 is also 3.31 volts. So Q3, C3 delta V3 is 9.9 microcoulombs. Right, and we're done.